Hi there. We're going to be dealing with normal distributions today using a method which is different from what the books use. I call it the Szekely cross, named after the woman who taught it to me. So this is the cross. So how we normally see a problem. So we have the probability that z is smaller than some number. We're going to use 1.41. Okay? Now if you look at the back of the book, this is exactly how the problem is set up, so we can just read off that is 0.9207. 0.9207. There we go. That's it. Now because we're calling this the standard one, we say this has 0 changes. Okay, now if I was to draw the graph, so you can see it as you may have seen it before, what we are looking at here, now it's z, so that's 0, we're looking at 1.41 and we're trying to find this area. So that looks about right. Okay, next one. This time, rather than dealing with the probability of z is smaller than, we're going to look at how do we deal with the probability that z is bigger than 1.41. Okay, now what we'd say here is there is one change. This smaller than sign has become a bigger than sign. So we say there is one change. Okay, so because there's one change, this no longer equals 0.9207. This equals 1 minus 0.9207. Or in other words, it equals 0.0793. Okay, one change because of that one change. And if we were to draw it, we are looking for it to be bigger than this area here. So you'd expect it to be the 1 minus the area the old one was. Okay, that is our second section. Okay. Third section. This time we're going to deal with probability that z is smaller than minus 1.41. Again, this is one change from our original up here, where it was smaller than and this was a positive number. It's now smaller than a negative number. So we say we have one change. And that is, again, 1 minus 0.9207. So that one also equals 0.0793. So, if we now draw that, we're looking for it to be less than here. Okay, so we're looking for this area, and again we expect it to be 1 minus this area to get that area. So that's our third quadrant. So we have our change there. Okay, last one then. The probability that z is bigger than minus 1.41. Okay, this time we have two changes compared to the original. We're a bigger than and a minus. So it would be 1 minus our number, which would give us 0.0793, and then 1 minus that, which would give us back our original. So this just gives us the same number as if we had no changes. 0.9207. Okay, so this is two changes. And if you want to see that, that's 0. We're down here, minus 1.41, and we are looking for this. So, how to deal with this in general? If you have the probability of z being smaller than a positive number, you just read that off your table. If you have probability of z being bigger than a positive number, you do 1 minus that number. If you have probability of z being smaller than a negative number, again you do 1 minus because it's one change. And finally, if you have probability of z being bigger than a negative, it's 2 changes. And then you put the original back in again. Now, you will notice at most books you are given actually 2 tables to calculate normal distributions. One of them will give you the probability of z being smaller than a number, and you have numbers between 0.5 and heading up to 1, and the other one will give you bigger than positive numbers, and will give you that. So you can see how this switch is already used, and if you were given a problem like this in the back and you wanted to convert it to that, all you would do is you'd swap your sign and you'd do 1 minus this probability in order to find it. So that's forwards in the Szekely cross. Next we're doing backwards. Okay, backwards. Put that up there. Draw another cross. Now this time, rather than being given the z value, we're going to be given the probability. So the probability that big Z is smaller than our number equals 0.8051. Okay, this is how you would expect to see the question. Its probability of z is smaller than z, and you're given 0.8051. Now that number is bigger than 0.5, and so this is exactly what we would expect to see. If you read this off the table, exactly as it is, you get that z equals 0.86. Okay, so this is 0 changes. Okay, and if I draw it, what we just got was there is 0, here is our unknown z value, and we were told that this area was 0.86. Now you see it's bigger than 0.5, and therefore it's to the right of this 0. Okay, that's what we're expecting. So now we're going to deal with a slightly different sort of problem. The probability that we're looking at something which is bigger than an unknown point. Okay, and in this case we are told that it is still a positive number, 0.8051. Now, how many changes have we got compared to the original? Well, it's just this bigger than sign. Okay, so much like before, we now have one change. But don't suddenly go, we're going to do 1 minus, because we're not. I'm going to draw this time first. Okay, what we have just found is being bigger than z is a number that's bigger than 0.5, which means that z must be down here. First point here is 0, right? Which means that z must be a negative number, and that is what our one change has told us this time. Okay, this area here is 0.8051, and so we now know that z is just negative 0.86. That is what our one change does. It swaps from being a positive z value to being a negative z value. Okay, our third problem. Probability in our region of being smaller than z equals 0.1949. Now this time, rather than having a number that's bigger than 0.5, we have a number that's smaller than 0.5 here. Okay, again, that's one change. And if I draw it, with that being 0, we are smaller than a number and we're getting something smaller than 0.5, sorry. Therefore, we must be talking about this area. Okay, 0.1949. So, again we got one change, which makes it just a negative. Z equals minus 0.86. So now it's time to deal with our last section. The probability that Z is bigger than small z is 0.1949. Now this time we've got a change in that and a change there. So we have two changes. You notice this looks quite similar to what the forwards Szekely cross looks like. So two changes, so it'll be 1 minus and 1 minus. So we're going to get out that Z equals 0.86. So let's draw it. We're down here with 0. We are bigger than a value, and that bigger than gives us a number less than 0.5, so we must be here. 0.1949, and that's Z. Now you will notice that this is how the smaller table at the back of the book is given. And you notice that that has 0 changes to that. So if you are looking for the probability of Z being bigger than Z to be a number less than 0.5, you can just swap it right around to be probability of Z smaller than Z, and you just do 1 minus that to get this. And that is the backwards Szekely cross.